200 million years. That is how long this creature has dominated the waters of our planet. Long before the first mammals walked, it shared the Earth with the dinosaurs, watching their entire empire rise and eventually burn to ash. When the planet plunged into the deep freeze of the Ice Age, this predator didn't falter. It adapted, endured, and waited out the cold. Yet today, people look at a crocodile sunbathing on a muddy riverbank and assume it's a sluggish, heavy, even lazy animal. To understand how it survived global extinctions without evolving its basic structure, we have to look past the muddy exterior. You are looking at a perfectly engineered biological submarine. Look closely at the jawline, right along the gums. You will find a series of tiny black dots called integumentary sensory organs. These nodes act as a localized, hypersensitive radar array. Even in pitch darkness, with the water completely still, this network can accurately detect the faintest heartbeat or the slightest vibration from a distant target. Once the radar locks on, the stealth sensors hand off the job to the heavy artillery. This chart compares the mechanical pressure of these jaws. An average human bite registers at about 160 pounds per square inch. A saltwater crocodile closes its teeth with 3,700 psi of pressure, a force comparable to the blast of a firing cannon. When those interlocking teeth finally pierce the prey, the crocodile immediately executes its signature mechanical maneuver, the death roll. By rapidly spinning its entire body mass, it leverages rotational momentum to cleanly tear portions from a target. It is the most efficient method to dismember a heavy catch in a fluid environment. By pairing a flawless sensory array with overwhelming hydraulic power, the crocodile becomes an inescapable trap. Moving deeper into the internal systems reveals an anatomy unlike other reptiles, a four-chambered heart, structured much like our own. Inside this heart lies a specialized mechanism known as the cog-teeth valve. This valve actively bypasses the lungs. It reroutes the flow of blood, steering it away from the respiratory system and sending it straight down into the stomach. This internal diversion conserves massive amounts of oxygen and energy, allowing the animal to sit completely motionless underwater for 2 to 3 hours on just a single breath. Down in the stomach, that redirected blood flow supercharges a corrosive chemical engine. The gastric acid is potent enough to completely dissolve solid bone and animal horns. It easily melts down the thickest armor in the ecosystem, including the solid shell of a turtle. To process these heavy meals, the crocodile utilizes one final piece of internal engineering. It swallows heavy stones called gastroliths, which act as a mechanical grinding mill inside the gut. These stones also serve a vital secondary function. They act exactly like a scuba diver's weight belt, providing calculated ballast to maintain perfect underwater gravity and balance. Every internal life support system is precision-built for extreme stealth, efficiency, and endurance. The sensory nodes, the pressure of the jaws, and the bypass valves in the heart operate in total synchronization. This anatomy provides a level of efficiency that makes it one of the most successful predatory designs on the planet. It is a living fossil. Its physical form has remained untouched across millions of years because the underlying blueprint could not be improved upon. Eons ago, the wheel of evolution equipped this animal with a survival toolkit so robust it easily outlived the largest giants to ever walk the earth. The crocodile remains a finished specimen as biological engineering, a design so effective it has outlasted the giants of the past.